So we have a lovely test here. This is it's called Math 2650 locally, but we also call it Calculus 3, Exam 1 from Spring 2025. So this particular exam deals with our basics of geometry and a little bit of parametric curves. So starting to build up our geometrical understanding, very important if we're going to do well in multivariable calculus. We have 6 multiple choice and 4 workouts, so plenty of work for us to do. And for this test, we have a convenient formula sheet, and so we're going to have that handy should we need it. And all right, good. Well, as always, before we begin, make sure we write our name, because if we don't put our name, we're not going to get the credit, and we want all the credit for our great work. Let's get going. Number 1. Which of the following describes the region given by the inequalities? 0 less than or equal to z, z less than or equal to 1 minus square root of x squared plus y squared. So notice here it really is 2 inequalities. So we have the first pair, 0 less than or equal to z, and the second, z less than or equal to 1 minus the square root of x squared plus y squared. Now the first one, the 0 less than or equal to z, we could write that as z greater than or equal to 0. And we say, that just says our z coordinate is greater than or equal to 0. Now, what does that really say? Well, z equals 0. Think about that. Z equals 0 is the xy plane. And now we're greater than or equal to 0. So we have to be above a plane, right? The lower bound, right, this is below z, is a plane. And so you'll notice a few things. Bounded below by a plane, okay, by a plane, good, by a paraboloid, nope, not going to happen. By a sphere, nope, by a plane, okay. So now we have narrowed down. Okay, so it's one of the others. Now we go to the second part of the inequality, and we have z less than or equal to 1 minus square root of x squared plus y squared. Now there's a couple ways to do this. If you say, hey, z equals square root of x squared plus y squared, I just happen to know that this is a cone that looks something like that. Well, minus does what? It flips it upside down. And then 1 does what? It shifts it up. So this is an upside down cone. That just happens to have been shifted so that the top of the cone, the tip, is at z equals 1. So the top should be a cone. Well, that's not a cone, and that's not a cone. So we now know the answer is A. Now, the other way to do this is to say, hey, square root of x squared plus y squared, what is that? Well, you could write that in polar coordinates, but really, because we're in 3 dimensions, cylindrical coordinates, and say this is the same as 0 less than or equal to z less than or equal to 1 minus r. There's no theta, so we have nice symmetrical around the z-axis. We can spin it. And so if you think about the RZ plane, you'd say, well, I have to be greater than or equal to 0, so I'm up here. And z equals 1 minus r is down there. And you say, okay, that's your region. And now spin. And we say, aha, yes, it is indeed a cone. The bottom is a plane, the top is a cone, which is exactly what A says. All right, number 2. The 2 planes, x plus y plus 2z equals 7, and 3x minus z equals 5, intersect along a line L. Choose the vector that is in the same direction as, i.e., parallel to L. All right, so in essence, they're asking us, what's the direction vector of the line? Now, let's talk about this problem. Let's talk about the intended way that they want you to solve it, and let's talk about sort of a faster way. Okay, so let's do the intended way first. Now, what do we have? We have a line that's in 2 planes. And so we know that since L is in both planes, well, what does that say? Well, it says that the direction of L is in both planes. So we say, we need to be perpendicular to our first normal And what is that? Well, you come up and you read off the coefficients. And you see a 1, 1, 2. So 1, 1, 2. And you have to be perpendicular to the second normal. So you come up here, you see a 3 and a minus 1. You say, well, hold on, there's no y. What do you do if there's a missing variable? We have ways. If it's a missing variable, treat it like a 0. So in our case, the coefficients are 3, 0, minus 1. All right, well, hey, if you have something that's perpendicular to two things, something should cross your mind, right? Yes, cross product, booyah! So the intended approach is to do a cross product, so let's do that. All right, so we set it up, and, I will say, you can almost always predict on these exams, there will be a cross product at some point. There will be a dot product at some point. So be ready, be ready. All right, so we have minus I, doing my diagonal, 6j, and 0k, and then we have 3k, but subtract it, 0i, but you subtract. Well, it's not hard to subtract 0. And then you have minus j, but you subtract that, so you have minus j. And so what does that give us? Well, it gives us minus 1, 7, minus 3. And we're like, okay, do any of these vectors look like minus 1, 7, minus 3? And we're like, wow, that's the answer, D. And we're like, booyah, done. Now, the reason I say this was the intended way to do this is because this is the way you would do it if it wasn't multiple choice. But it is multiple choice. And sometimes you can say, oh, I can do something different. Namely, we can say, look, we have to be perpendicular to the normal. That's still true. So let's just say I'm going to be perpendicular to 1, 1, 2. And now do a quick check with your dot product. And you say, what? What do you mean by that? Well, I just have to check. Remember, to be perpendicular, I just need to look, does u dot v equal 0? So we're going to do the dot product with 1, 1, 2. 1 plus 1 plus 4, not 0. 3 plus 0 minus 2, not 0. 4 plus 1 plus 2, not 0. Minus 1 plus 7 minus 6, that's 0. So D is still on the table, right? So we've knocked these out because the dot product with 1, 1, 2 isn't 0. Now here, 3, 0 minus 4, not 0. Knocked out, and we're done. So we can check our answer. Because we know it has to be perpendicular to both normals, just doing a quick set of dot products, and we get our answer. And so, hey, both ways get you points, right? Because when we're doing multiple choice, we're not being tested on, did you do it a particular way? It's like, do you have the right answer, or do you not have the right answer? And so, figure out how to get the right answer, right? That's the goal. That's the goal. Number 3. Let A be the vector 1x minus 2, and B the vector 3, 2, 4. And they're two vectors in three-dimensional space. If A is orthogonal to A plus B, what is a possible value of x? Now you see orthogonal, and orthogonal is another way of saying perpendicular. Now, how do we check if two things are perpendicular? Well, the answer is we use the dot product. So what we know is that A dot A plus B has to be 0. So I say, well, what's A? Well, that's 1x and minus 2. What's A plus B? Well, now you just add the corresponding entries. 1 plus 3, 4. X plus 2, x plus 2. Minus 2 plus 4, 2. Okay, so we quickly multiply here. We get 4 plus x times x plus 2 minus 4 equals 0, right? So you have 4 and minus 4. Well, that's really very convenient. So what does that tell us? Well, it tells us that x times x plus 2 has to equal 0, which gives us two possibilities. X equals 0 or x equals negative 2. Now, so that says there's multiple possibilities. However, we know what is a possible value of x, not what are all the possible values of x. Negative 2 is not on our list, but 0 is. So the answer is 0. That is a possible value. So, be careful, right? It's not claiming what are all the possible values, but what's the one that works? Okay, so that's number 3. Number 4. At a certain moment, an object moving through space has an acceleration in its direction of motion given by the vector ATT equals 1, 1, 1, and an acceleration normal to its direction of motion given by the vector A sub nn of minus 1, 2, minus 1. What is the magnitude of the object's overall acceleration at that moment? All right, so what have we been given? Well, we're told we know this vector, it's parallel to motion, that's ATT. So AT is the magnitude, T is the direction. We also are told, hey, there's this other vector, it has to be perpendicular to T, right? These are purposely perpendicular to each other, and that's ATN. And the punchline here is that these are the decomposition of acceleration. And so you say, oh, well, that means that the acceleration here, that's the sum of these two vectors. So we can say the acceleration is 1, 1, 1, this piece, plus minus 1, 2, minus 1, that piece. And if we add those together, we get 0, 3, 0. Okay, so that's the acceleration. Now, what's the question? What's the magnitude? So the magnitude, well, that's the square root of 0 squared plus 3 squared plus 0 squared. Oh, okay, I can ignore that. Square root of 3 squared is 3. So our answer is magnitude of acceleration is 3. All right, great. That wasn't so bad. We're doing wonderful. 2 more multiple choice to go. Number 5. Find the vector v that is in the same direction as 1, 0, 7 and has magnitude root 2. So we're saying here's a vector. I like its direction. I don't like its magnitude. So what do we do? Well, one thing we can say is, well, when we think direction, oftentimes we think of unit vector. So we say, okay, let's do this in sort of 2 phases. If I start with the magnitude of 107, what would that be? Well, it's the square root of 1 squared plus 0 squared plus 7 squared, which is the square root of 50. And, okay, well, not much we can do with that. I suppose, what can we do with that? Well, square root of 50, that's 25 times 2, right? And so we could say, okay, that's 5 root 2. All right, that's the current length. So idea, step 1, we'll do a unit vector with the right direction. So you take 1 over the magnitude, 1 over 5 square root of 2 times 107. Now, this has magnitude 1, the clue being the word unit. Now, we say, okay, now that you have the right direction nailed down, we now scale it so it has the right length. So our desired vector would be do what? Well, it's going to be square root of 2 times 1 over 5 square root of 2, 107. And we say, the square root of 2's cancel. Almost like they wanted them to cancel. I think they did want them to cancel. And, well, we can multiply the 1/5 through, and we get 1/5, 0, and 7/5. And there's our answer, and it matches. Beautiful, beautiful. And there you go. Now, you could do a couple of things alternatively. You can certainly say, hey, some of these can't work. B is definitely out. Why? Because that's not a multiple of 107, because that's a 2 and a negative 14. And then you could go through and find these lengths, but I think that might be a little bit too long. And so this feels like about a good amount of work. So, all right, that's number 5, bringing us to our last multiple choice problem. The points P, -251, and Q, 617, are the endpoints of a diameter of which sphere? So, as a reminder, diameter, it says you go all the way across. So a radius does from the center out to the edge of the sphere. So one way to think of diameter is essentially it's like 2 radiuses. I think you'd probably say radii. All right, so that's our idea. And now when we say we go all the way across, well, in particular, we go from like a north pole to a south pole. Those points which are directly opposite. So, if we start back in the back, we'll come out the front, and you'll notice we will cross through the center. So, idea. This is going to involve midpoint. So we say, okay, so the center of our sphere is equal to our midpoint. And all right, well, that's going to help narrow things down quite a lot. So let's figure out what our midpoint is. So, well, you're going to add and divide by 2. So -2 plus 6 is 4. Divide by 2 is 2. 5 plus 1 is 6. Divide by 2 makes 3. 1 plus 7 is 8. Divide by 2 makes 4. So our center is 2, 3, 4. Now, you might look at A and say, 2, 3, 4. Ha, that's right? Oh, be careful, right? Because our center, you have to do minus. So it's x minus h squared, y minus k squared, z minus l squared equals r squared. So we're looking for x minus 2, y minus 3, z minus 4. So A is out, C is out, D is out. But B, x minus 2, y minus 3, z minus 4, x minus 2, y minus 3, z minus 4, they're both in. Okay, well, what's the difference? Well, the difference is this right-hand side. So we got to figure out, okay, what's the radius? Well, for that, we say, hey, we go from the midpoint to either one of these. Doesn't matter which one. So let's go from 2, 3, 4, and we're talking distance at this stage, from 2, 3, 4 to, let's say, 6, 1, 7. All right, that's going to be the square root of 2 minus 6, so -4 squared. So it's the change in y. 3 and 1, that's, which way did I go? Why did I say it's -4? Okay, so I took this minus that. 2 minus 6. 3 minus 1. 2. I just want to be consistent. 4 minus 7. -3. Honestly, because you're squaring, we would have been okay. All right, we get what? Well, we get square root of 16 plus 4 plus 9, which makes it square root of 29. Now that's our radius. We got to square that, meaning our radius squared is this part, 29. So there's our answer. Now notice they did something a little sneaky here. And E is fairly tempting because if you think about what E is, it's the right center. This number 116 is if you go not from center to point on the edge, but if you went between these two. So in other words, if you misinterpreted the relationship between diameter and radius, you would have put 116. Oh, they're sneaky like that. Sometimes they'll put options on the multiple choice that are like, hey, are you paying attention? We know the kind of mistakes you make, and we're going to put them there. So be careful. Don't rush through it. Take your time. You've got time. We're doing great on time. We only have 4 problems left and plenty of time to do it. I believe in us. Number 7. We're into the workout. A region is defined by the following inequalities. So we have 3 inequalities here. And one thing that quickly jumps out is we see things like we see a rho, we see a phi, and That's all we see. Okay. There's no theta, so we have beautiful symmetry going around the z-axis. Always got to like that symmetry. Beautiful. But in particular, it's saying, hey, we are in our spherical coordinate system. So that's good to know. All right. And so we have these three, and we'll go through them. In fact, that's sort of the point here, is to go through them. And it says, hint, below are some surfaces to help with visualization. And note that the image does not indicate the volume defined by the inequality. So this is going to be interesting, but we'll figure it out. Let's start with part A. Rewrite rho sine phi less than or equal to root 2 in Cartesian coordinates. Now, we haven't pulled out our formula sheet yet, but we can, because we say, hey, rho sine phi, that shows up in a very convenient place. There's the rho sine phi. And so we say, hey, rho sine phi, that's equal to r. Word! Okay, so what we'll do is we'll say that we can rewrite this as r less than or equal to root 2. Now the problem is that's not Cartesian, that's cylindrical. But you'll notice we also have another formula that says, oh, x squared plus y squared equals r squared. So if you square both sides, you get r squared less than or equal to 2, or x squared plus y squared is less than or equal to 2. So that's part A. Now let's think about that in terms of our figure. Well, we are told that x squared plus y squared is less than or equal to 2. X squared plus y squared equals 2 is a circle. It's a circle in the xy plane. Because there's no z, it's a circle copied up and down. So what do we get? We get the cylinder. So we are told we are inside the cylinder. Okay, so we are on the inside of the cylinder. So first observation, inside our cylinder. All right. Good to know. That's the first one. Let's go to the second one. Part B. Rewrite rho plus 2 root 2 cosine phi greater than or equal to 0 in Cartesian coordinates. All right, well, that should be interesting. Now, cosine phi shows up right next to the one we circled. It's right here. Notice rho cosine phi is equal to z. Aha! Okay, so how do we use that? Well, we say, great, we want a rho cosine phi. Well, that's not rho, that's 2 root 2. So we say, well, let's make it a rho. Not that we're going to replace the 2 root 2, but we say we're going to put a rho in there somehow. And the easiest way to do that is we'll multiply both sides by rho. Now, we have this understanding that rho measures distance out from the origin, so we don't need to worry about, oh, is that going to do something with our inequalities? Because, no, rho is a non-negative quantity, so we're good to go. All right, so we get, if you multiply through by rho, rho squared plus 2 root 2 rho cosine phi is greater than or equal to 0. And I should point out that, we get this other formula. Rho squared equals x squared plus y squared plus z squared. Nice. Okay, so we get x squared plus y squared plus z squared plus 2 root 2z is greater than or equal to 0. Well, that feels sphere-like, because if you see x squared and y squared and z squared, you think sphere. Well, but what sphere? Well, to do that, we would want to complete the square. And the x's and y's, they're good to go. The z, not yet. The problem with the z is that you have this 2 root 2z. So I say, okay, what do we do there? Well, we'll add and subtract, right? Or alternatively, you can think of add to both sides. You say, okay, take what's in front of the z coordinate, which is currently, it's 2 root 2, divide that by 2 is root 2, square that, and you would add 2. So we're adding 2 to both sides. And now you say, oh, this becomes x squared plus y squared plus z plus root 2 squared is greater than or equal to 2. Now, I will point out this is a correct answer. This is a correct and more useful answer. So both get full points. What is it saying? Well, it's a sphere. Where's the center? Center of a sphere, so we have a sphere. And the center is at 0, 0 minus root 2. And the radius is at root 2. Right? Just take the square root. And notice the inequality. Greater than or equal to. So we want to be on the outside of the sphere. Okay, so we want to be in the cylinder, but out of the sphere. And notice this sphere here, this is the point 0, 0 minus root 2. This point right here, which they didn't label, that's actually the origin, 0, 0, 0. Okay, so that's good. And we want to be outside the sphere. So nothing inside that sphere. Okay, good, good. We're almost there. We're almost there. Part C. Find the volume of the region defined by the three inequalities. Now, what we haven't talked about is this third inequality. See, we've done part A. We did part B. What does part C tell us? Well, it tells us about phi. Now, if you recall what phi is, we think of that in terms of how far are you coming off of the positive z-axis. So at phi equals pi force, we're coming off an angle of 45 degrees. At 3 pi force, we're all the way down to here. So this is pi force, this is 3 pi force. And now, if you sort of think about it, what's going on, say, well, there's no restriction on our theta, there's no restriction on rho, so you just say, imagine that you shade it, and now spin it. And so, if we put all this together, so let's do a cross section. We have to be inside the cylinder. We have to be between these two rays. So this ray right here, if we add this ray right here, this is phi equals pi force. Same as this side, phi equals pi force. This side, down here, phi equals 3 pi force. This side, again, getting crowded, but phi equals 3 pi force. We have to be in between these two rays. So we're in between, have to stay inside the cylinder, and we can't be in the sphere. So what region are we getting? We're getting this part right here. And then we're going to spin. So what is that shape? Well, it's, if I pull it to the side, just to help make it more clear what's going on, is we have there's a cylinder, but what we've done is in the top part, we subtract out a cone, and in the bottom part, we subtract out a half a sphere. So I'm shading the parts pink here that are being erased. Okay, so that's the idea. Start with the cylinder, delete a cone, delete a half sphere. And now we're like, oh, we're right there. We're right there. And the last thing for us to do is probably to mark some various quantities. We know that the radius of the circle, and it also corresponds to the radius of the cylinder, is root 2. This distance here will be root 2. And by symmetry, you look at this picture, this distance here is also root 2. Okay, so we have lots and lots of root 2's. But how do we find volume? Our formula sheet gives it to us. And in fact, we have all three volumes. We have volume of a sphere, volume of a cone, volume of a cylinder. And so we'll just go through and put it together. So we're going to take our cylinder, subtract our cone, subtract half a sphere. So our cylinder, the formula for that, well, I'll write them down. Pi squared h, 1/3 pi r squared h, and this is 4/3 pi r cubed. Okay, so good news. All the r's and all the h's are square root of 2. So we get pi times square root of 2 times square root of 2 times square root of 2. So that's 2 root 2 minus 1/3 pi times 2 root 2 minus 1/2 times 4/3 times pi times 2 root 2. Well, we can start doing some cancellations. And then we can say, well, hey, you know what? Everything here has a pi and a square root of 2. Let's factor that out. And let's see what's left. So from the first term, we have a 2. From the second term, we got the pi and the square root of 2, so it's minus, because don't forget minus, we're subtracting 2/3. From the last term, we got the pi and the root 2. We canceled the 2's, so we have minus 4/3. And, well, that's not going to work because that says minus 6/3, which is minus 2. Whoops, where did I screw up? You know, you can make mistakes. So let's double check what's going on here. All right, so we have our cylinder, pi r squared. Oh, I know my mistake. The h here is not root 2. The h of the cylinder is 2 root 2. So there's an extra factor of 2. I only did half of a cylinder. I feel silly. Sorry about that. So this would be a 4 here, right? That's why you check your answers and see if they're reasonable. 4 minus 2/3 minus 4/3 is 2. So we end up with 2 square root of 2 pi. There we go. Whoa. Oh my goodness, what a workout. But that's okay. We got there. This one is a bit of a challenge. And I can see because there's lots of notes I did along the way. But you have all the tools. You have all the pieces. Don't rush. Go at a steady pace. Number 8. Find all unit vectors of the form u is a comma b that make an angle of pi/3 radians with v equals minus root 3 and 1. Okay, so we have some clues. They even bolded some things for us. Unit, what does unit tell us? Well, unit vector says it has length 1. So we're like, okay, so the magnitude of u is 1. And I find it easier to square magnitudes when I can. And it turns out if you square 1, you get 1. Well, what does that tell us? Well, if we take the magnitude, we'll get, normally if we take a square root, the magnitude has a square root, but because we squared it, we don't need the square root anymore. We get a squared plus b squared. So that's a relationship. Now there's a second thing. It says an angle of pi/3 radians with v equals minus root 3, 1. Okay. Now, how do we do with angles? And the answer is down here. When you're dealing with angles between vectors, you think dot product. So we say, aha, u dot v is magnitude of u, magnitude of v, cosine theta. So that's going to be our go-to here. So here we go. We're going to say u dot v is equal to magnitude of u, magnitude of v, cosine theta. I'm just writing down the generic formula. And we say, well, u is a comma b dot v minus root 3 comma 1 equals magnitude of u, but use a unit vector, so that's a 1, times magnitude of v, which is square root negative root 3 squared plus 1 squared times cosine of pi thirds, because we know the angle. And the good thing is we can come here and say cosine of pi thirds, so this entry right here, that's a half. So say, okay, great, this is a half. And oh, by the way, what do we have here? We have 3 plus 1, square root of that, which is 2. So if you clean up, we get 0. All right, so now what do we have? Well, we have not 0, 1. I can multiply. 2 times a half is 1. So we get minus root 3a plus b has to equal 1. Nice. Now, that's another equation. So at this state, we say, let's put our equations together. 2 equations, a squared plus b squared equals 1, and minus root 3a plus b equals 1. Now, unfortunately for us, this is a little bit subtle because it's not just the 2 equations, 2 unknowns that we're used to. There's a square involved. That makes things a little bit more dicey, but not impossible. So how can we finish? Well, we can do substitution. So for instance, we can move this minus root 3a across, and that says b is equal to 1 plus root 3 times a. And now substitute into the first one. So we get a squared plus 1 plus root 3a squared equals 1. Now we have one equation and one unknown. Well, we start expanding. So you get a squared plus 1 plus 2 root 3a, so that's our middle term, plus 3a squared equals 1. We can cancel the 1's. We can combine the a squared, so we get 4a squared plus 2 root 3a equals 0. And now, if we pull out a 4a, what do we get? Right? Because here, we don't have 3 terms, we just have 2 terms, they both have a. So if you pull out 4a, we'll get a from the first term, plus, and here, root 3 over 2, because I have to divide by 4 to get that coefficient, right? Because if I pulled out a 4, then what's left I get by dividing by 4. And now we're like, oh, that leads us to 2 possibilities, namely a equals 0, or a equals minus root 3 over 2. So with that in mind, we're ready to head into the home stretch. Say, okay, now what happens if a equals 0? Well, b is 1 plus root 3a, so you get that b equals 1 plus root 3 times 0, which is 1, which gives us our vector 0, 1. All right. But there's a second one. If a is equal to minus root 3 over 2, then we get that b is equal to 1 plus root 3 times minus root 3 over 2. Okay, well, we say, what is that? That's 1 minus 3 halves, which is negative 1 half. And so our second vector is minus root 3 over 2, comma, minus 1 half. And there we go. So there were 2. And notice the question wasn't says find 1, but says find all. So it's quite possible that we got more than 1. And in this case, we did. There were 2 of them. And, well, there you go. There you go. And, all right. Well, we're making lovely progress. And let's go to number 9. The line given parametrically by the equations x equals 1 minus 2t, y 4 plus 6t, and z 3 plus t is parallel to the plane through the point P0, 172 with normal vector 2, 0, 4. And then there's a question. Calculate the distance between the line and the plane. Now, how can we do that? Well, wouldn't you know, we have our nice formula down here. And you see it says there's a little dot and a little plane. So that's point to plane. And it says, hey, here's how you find the distance from point to plane. So it's like, what? That's going to be easy. So we need to write down our plane. Say, okay, what's our plane? Well, we have 2, 0, 4. So that says those are our coefficients. 2x plus 0y plus 4z equals something. And now the age-old question, what's in the box? What's in the box? Well, to figure that out, that's where we use our point. Okay, so we have 1, 7, 2. So we're going to plug in. So 1 for x, 7 for y, and 2 for z. And if we do that, we'll get 2 plus 0 plus 8. All right, well, that makes 10. All right, so our plane is 2x plus 4z equals 10. Now, our point. So, what's the point? Well, the answer is, hey, we're going to reduce the problem from line to plane, point to plane, and every point on the line is the same distance to the plane. So just find a point. Doesn't matter. Pick one. Any one. So the easiest one you can imagine is just plugging in t equals 0. So that would be 1, 4, and 3. Okay, and another way to see this is if you write this, I like to write parametric form, a little stack. X equals 1 minus 2t, y equals 4 plus 6t, z equals 3 plus t. And then you just say, hey, the constants, those are a point. Okay, so that's the point. And then you say, and then the coefficients in front of t, that's the direction vector, which in this case, we don't need that. It's not going to come into play in our solution. All right, well, so what was the formula? I'm going to write it down. So here we go. Point, plane. It says ax0 plus by0 plus cz0 minus d. All of that divided by the square root a squared plus b squared plus c squared. All right, I'm just copying it straight from the formula sheet. I don't have to memorize things. I just have to know how to use things. Knowing how to use things is more important. Okay, so how do we use this thing? Well, there's a couple things. The x0, y0, z0, that's this part, x0, y0, z0. The a, b, c, d, that's your coefficients. You have ax, by, cz equals d. So for us, what do you do? Well, essentially what you do is you plug the point into this equation, move everything over to one side, and just see how far off are you. So we're going to take not a, I'm going to use actual numbers here. So 2 times 1. Now, there's no y. Don't worry about it. If you're missing a variable, that just means your coefficient is 0. So plus 0 times 4 plus, and then c is 4. So 4 times 3 minus 10. So how far off are these two sides if you plug in the point? That's what the top is asking. Divide by the square root, and now the normal vector from your coefficient. So you get a, 2 squared, b squared, 0 squared, and c squared, 4 squared. And I just realized after doing all of this, I could have made my life much simpler. I could have just divided everything by 2. I don't know why I didn't do that. Well, you don't have to. You'll still get the same answer, but all right. On we keep going. So we get what? Well, we get 2 plus 12 minus 10. Upstairs, downstairs we get the square root, 4 plus 16. Well, 2 plus 12 minus 10 upstairs gives us 4. And over square root of 20. This is perfectly fine, but we can do a little bit better. Square root of 20 is, there's a factor of 4 we can bring out. So that's 4 over 2 square root of 5, right? You might say, I thought you said it was a 4. Well, square root of 4 is 2. And we can divide that. And so we end up with 2 over square root of 5. So there we go. And so that's the idea. Use your formulas, right? Know how to use it. And in particular, say, hey, can I reduce to a simpler problem? And a lot of distance problems you can reduce to, say, point to point, which is distance formula, point to line, that involves the cross product, and point to plane, which secretly doesn't look like it involves anything, but it involves a dot product. So we have our tools. They're all there. We use them. We use them to succeed because we like to succeed. Okay. Well, that brings us to number 10. Our last one. And I think we have plenty of time. So let's enjoy it. Suppose that r of t is 1/3 t cubed plus t squared j plus 2tk traces the path of a particle at time t greater than or equal to 0. Okay, so we're motion of a particle. Find the velocity of the particle at time t equals 2. So velocity, when we talk about velocity, this sometimes we use v of t, but this is the same thing as r prime of t. And note, velocity, this is going to be a vector. So be careful. We're not asking speed. Speed is number. We're asking velocity. Velocity is vector. So pay attention. So what do you need to do? Well, I like to write things in component form, so I'm going to go ahead and do that. There's no reason not to. You can leave it as ijk, but I just find it easier just to say I want to work in every slot, and this just helps me keep things organized. So r prime of t would be, take the derivative of each one, derivative of t cubed, the 3 comes down, so we get a t squared. Derivative of 2t squared is 2t, and the derivative of 2t is 2. Well, that's very nice. Now, that's not the answer. That's the answer at generic time. We want a specific time. And so to get our answer, what do? We plug in 2. So we say, okay, the velocity at time 2 would be 4, 2 squared, 4, 2 times 2, and 2. 4, 4, 2. And that's part A. Okay. Oh, that was pretty good. And look, we already got 4 points. Yes! All right, we're going to get a lot of points on this test. That's our goal. Get the points. Get the points. Part B. Find the distance traveled by the particle between time t equals 0 and t equals 3. So we say, oh, we have a distance and there's a particle. And we say, well, we can remember the formula. It's not on our formula sheet, but it has a nice little form. You add up integral a to b, and you integrate speed. So the integral of speed is distance, and that's just a very simple thing. If I know how fast I'm going, and I think about, okay, speed times dt is the little distance I travel, out of all the little distances, I get total distance. Speed is the magnitude of velocity, so it's magnitude of r prime of t dt. Okay, now with that we say, so the bulk of the work, I like to say, probably like, I sometimes exaggerate and say 90%, but it's true, is can we find this piece? And the challenge is that magnitude involves a square root. And square roots are, we don't like them. They're messy, especially if we have to integrate with them. So we want to get rid of the square root. And so they've written the problem in a way that we can probably either get rid of the square root or find a way to sort of integrate around it in some fashion. Okay, so we have r prime of t right up here. So we don't have to reinvent the wheel. So square root of, we square the first entry, plus square the second entry, plus square the last entry. Okay, so that's going to be the square root t to the fourth plus 4t squared plus 4. And, okay, that looks very promising, right? This looks like this should be like our t squared squared. This, I'm going, because we've sorted them by decreasing power, this looks like it could be a good 2 quantity squared. And if you look here, this looks like 2 times t squared times 2, 4t squared. Which means that we're really dealing with the square root of t squared plus 2 squared. And lo and behold, square root of a square, assuming what's on the inside is positive, is just what's on the inside. And, well, t squared plus 2 is certainly positive. So we're ready. So for us, our distance, we have our a up here, 0, and our b, 3. So integral 0 to 3 of t squared plus 2. Okay. Well, cool. That becomes what? 1/3 t cubed plus 2t. And we evaluate from 0 to 3. The good news is it's very easy to plug in 0, and you get 0. So most of our time will be plug in the 3. Okay, so that's going to be 1/3 times 3 cubed plus 2 times 3, and subtract the 0. Well, 3 cubed is 27, but really you can say, oh, cancel out a 3, so it's like 3 squared. So we get 9 and 6, which means our distance is 15. We don't have any units, so we just say 15, and we're done. And we're done. That was it, our final problem. And of course, don't stress too much, but it's not a bad time to go back and revisit all of our problems because we had a lot of them. And some of them made us think a lot. Well, that's not a bad thing. We like it. That's one of our pastimes if we work in math. All right, well, that was a fun ride. Thanks for going through and working the test with me. I hope you do well. Make sure you're practicing. You gotta do the practice, but you can do it. Use your resources. Learn about all the things that are on your formula sheet. There's some good stuff in here. There's volume stuff. There's converting between different coordinate systems, some trig stuff, and very useful stuff down here. Know your tools. Use them well. You can succeed. I believe in you. Thank you for joining me, and I hope to see you again.